All right, welcome to 2.4 day 1. We're going to start out with a couple warm-ups. The sine of angle C. The sine of angle C is the opposite, which is 8, over the hypotenuse, which is 17. Now the cosine of angle C is the adjacent side, which is 15, over the hypotenuse, which is 17. The sine of angle E again down here, the sine of E is 16 over 20. Since we're not using clickers, we can just reduce that. We can both divide those both by 4, so that would be 4/5. The cosine of angle F. Now we have to look at angle F. Cosine of angle F is going to be 16 over 20. Again, divide by 4 to get 4/5. Alright, so there's the answers. Now, a little review of trig. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. 3 new ratios that we're going to learn today are cosecant of theta, secant of theta, and cotangent of theta. So cosecant of theta is hypotenuse over opposite, secant of theta is hypotenuse over adjacent, and cotangent of theta is adjacent over opposite. So now if we wanted to find the tangent of angle A, tangent of angle A is the opposite, which is 5, over the hypotenuse, which is 13. The cotangent of angle A, we know the cotangent is, did I do that right? I didn't do that right. So I made a mistake. I just went through that real quick. Opposite over adjacent, adjacent would be 12. Now, if I look at this, cotangent of angle A, I have adjacent over opposite, which is 12 over 5. Cosecant of angle A, cosecant of angle A is going to be the hypotenuse over the opposite. So we're going to get 13 over 5. The secant of angle A is going to be the hypotenuse over the adjacent side, which is 13 over 12. Now the secant of angle D. Secant of angle D, again we have hypotenuse over adjacent. Hypotenuse is 17. Adjacent is 8. Cotangent of angle D. Remember, that's adjacent over opposite. Adjacent side is 8. Opposite side is 15. All right, now let's look at the relationship between sine, cosine, tangent, and cosecant, secant, and cotangent. Notice that cosecant and sine have a relationship where they're reciprocals, which means the fraction is just flipped over. Same with cosine and secant, tangent and cotangent. One way a lot of people can remember these is each pair has a co in it. Now, this doesn't have an O, but we know this is cosecant. So there's a co in there somewhere. So sine matches with cosecant, cosine matches with secant, and tangent matches with cotangent. Now, these have reciprocal properties, like I said before. So cosecant is 1 over sine, secant of A is 1 over cosine of A, and tangent of A is 1 over cotangent of A is 1 over tangent of A. Now, this is really important when we're plugging these into the calculator, because our calculator doesn't have a secant button. Now, sine of 52, if we wanted to find the answer to this, you just plug it in your calculator, sine of 52, and your answer would be 0.7880. If you don't get that answer, check to make sure that you're in degree mode. Now, for secant of 22, your calculator doesn't have a secant button, so we need to push 1 over cosine of 22. So I'm going to go to my calculator, 1 over cosine 22. That's 1.0785. Cotangent, that's going to be 1 over tangent of 37, not 77. Alright, so if I do that on my calculator, 1 over tangent 37, 1.3270. 1.3270. Find the cosecant in fraction form of the standard position angle with a point -6, 8. So if I move to the left 6 and up 8, I want to find the cosecant of our angle. So if this is 6, that's 8. You can use Pythagorean theorem, or you can just know a 6, 8, 10 triangle. So we have 6, 8, 10. Now, cosecant is hypotenuse. Since it's co, it's going to match up with sine. So over opposite. So our hypotenuse is 10. Our opposite side is 8. 10 over 8 is our cosecant. Now find the exact value of the secant of the angle that passes through the terminal point 5, -2. So let's go 5 to the right. We're going to go down 2. Now this isn't such an easy triangle, so we're going to have to use Pythagorean theorem to find out our hypotenuse. So it looks like it's going to be the square root of 29. Alright, so now we want to find the secant of theta. So if we look at the secant of theta, secant is the hypotenuse. It has to match up with a co, so it has to be cosine, so over adjacent. Now the hypotenuse is root 29. The adjacent side is 5. So root 29 over 5 is the correct answer. Now find the exact value of the trig ratios that form -6, 1. So that means I go to the left 6. I go down 1. I'll throw that on top there. Alright, now we have to find that hypotenuse. So 1 squared plus 6 squared equals c squared. 1 plus 36 is 37. So the square root of 37 is our hypotenuse. Now if it says find the exact value of all 6 trig ratios, we have to do sine, cosine, tangent, cosecant, secant, and cotangent. Now I line them up like this just because it's a little bit easier this way. Sine is -1 over root 37, which can rationalize to negative root 37 over 37. Cosine is -6 over root 37, which can rationalize to -6 root 37 over 37. Tangent is opposite over adjacent, so -1 over -6, which is just going to be 1 over 6. Can I move these? Yeah, I want to move these over a little bit just so we can see it. So cosecant of theta is going to be the reciprocal of this. So negative root 37 over 1. So over 1 doesn't do much. Oh. No. Hopefully this doesn't lose it completely. Alright, now let's do negative root 37 over, it's supposed to be a 7, over 6, which is just the reciprocal of cosine. And cotangent is the reciprocal of tangent, so 6 over 1, which is just 6. Alright, now here's a couple problems you can go through. The if I want to find the 6 trigonometric ratios, if cosine is negative 5/13, we'll go 5 to the left over the hypotenuse, which is 13. This third side is going to be 12. So this is in, but it says quadrant 3. So let's do that again in quadrant 3. So I go 5 to the left. The hypotenuse is 13. This side here is going to be 12 because it's a 5, 12, 13 triangle. If you don't know how to do that, you can use Pythagorean theorem to find that out. So now it says find the 6 trigonometric values. So we have sine, cosine, tangent, cosecant, secant, and cotangent. So the sine is negative 12 over 13, opposite over adjacent. Cosine is negative 5/13. Tangent is 12 over 5. The negatives will cancel out. Cotangent is, or cosecant is 13 over negative 12, so we just throw the negative on the outside. You should never put a negative in the denominator. Secant is 13 over the adjacent, which is negative 5, and cotangent 5 over 12. Now we're going to try to do sine of theta is 12/13 in quadrant 2. So we'll draw a triangle in quadrant 2, 12 over 13. This side is going to be 5, again a 5, 12, 13 triangle. Now this is negative because we're moving to the left. Now we'll write sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant theta, and cotangent of theta. All right, the sine is opposite over hypotenuse, 12 over 13. Cosine is negative 5 over 13. Tangent is negative 12 over 5. Cosecant is just the reciprocal of this, 13/12. Secant is the reciprocal of that, negative 13/5. And cotangent is negative 5/12. All right, that's it. There's your homework.